And with no further ado, let's get on to our feature presentation where we're going to be talking about empowering analytics, unleashing the power of Dremio Cloud and Microsoft Azure. Joining us today, we have Hanno Borns, Principal Product Manager over there at Microsoft Azure, and Johnny Dixon, Senior Product Manager here at Dremio. With no further ado, Hanno, Johnny, the stage is yours.
Hi, everyone. My name is Johnny Dixon. I'm a product manager here at Dremio, and I cover Dremio Cloud. Now, today is an exciting day, as what we're going to be doing is introducing Dremio Cloud in Azure. This is something a couple of months ago we put out into the wild, into our public preview. And now what we're going to do is we're going to jump into that in more depth, walk you through how this is constructed and the value that people can get out of it. We're going to walk through how Dremio Cloud in Azure eliminates the pain of managing infrastructure and makes customers more productive in a shorter period of time. If we look at Dremio Cloud as a general overview, what we'll see is that there is a split plane architecture. In that split plane architecture, the control plane is hosted by Dremio. Now, what that means is that the Dremio infrastructure is accessible from anywhere, whether or not that's within an organization or or outside of the organization, as well as within different countries, meaning that people can access this from anywhere, as well as meaning that it's accessible at any time. The execution plane is hosted within the customer's tenant, meaning that you can ensure that there is security on top of your data. You can have that security and governance. Now, when we look at the cloud features themselves, we'll drill down into pieces around our next generation architecture and how it achieves all of those things I've just said. Dremio Cloud also has zero downtime upgrades. Now, what that means is that from a management side of things, there is then nothing that's required from a customer around performing upgrades. Dremio Cloud will take care of that automatically. And the instance itself will be accessible throughout the time an upgrade is taking place. There is also zero setup and management overhead, meaning that it is incumbent upon Dremio to ensure that when we're performing our daily activities, that things run smoothly. No longer does it require infrastructure teams within an organization to ensure that things are running smoothly. That now comes as part of the Dremio solution. There is also consumption pricing. This is highly beneficial for customers, meaning that they only pay for what they use rather than paying for something that may be sitting idle for a period of time. You also automatically get the Dremio latest functionality. We'll run through some of that when we go into our demonstration. All of this together means that we're going to be getting our quickest time to value. Now, as we dig down, I want to also run through the Microsoft side of things in Azure to ensure that we're covering the entirety of the solution. Let me now hand across to Hanno to walk us through the Azure part of things.
Hi, I'm Hanno, Product Manager at Microsoft Azure. I worked in various roles on system integration in the past, and the past couple of years focused on bringing large amounts of data into data lakes for analysis. I would like to outline on why partners like Dremio and its offerings like Dremio Cloud for Microsoft Azure are important to Microsoft. Initially, data warehouses were set up following a top-down design approach and were primarily suited for structured data. They had a pretty high TCO though. Later on, also semi-structured and even unstructured data had to be stored and be made available where traditional relational databases were not well suitable. This is the spot for Hadoop and similar software stacks. However, as there was a need to fuse both worlds for modern workloads and make data better discoverable, data lakehouses were established. These data lakes and data lakehouses became too massive for easy migration access, though. So the data mesh was born, which fuses multiple systems into one virtual system that is easier to run, support, and maintain. Security has always been a burden on these, and the more distributed teams are, the harder security is to be implemented. Azure Data Lake Storage empowers the data-driven digital economy as appropriate storage system. It's highly scalable, durable, and globally available. There's multiple layers of security. It integrates into your own security setup, and it allows to stay in compliance with legislation. It's very cost-effective, particularly if data can be cooled down, but that requires proper application design. There are comprehensive data management functions available that can also be applied by defining policies, and it supports a wide range of workload types. For instance, data can be stored for machine learning and AI. Data can be stored and retrieved for analytics and can be analyzed through software like Power BI. Others use it as storage for high-performance computing, business continuity, or even disaster recovery, and many use it for cloud-native applications. While Microsoft Azure provides the infrastructure and platform services, the real benefit for customers comes through a vivid partner ecosystem that customers can use to implement their workloads. And this is why Microsoft considers a partner ecosystem being so crucial for customer success. We're working with a number of partners in this space. I'm not going into detail on these, but particularly in the analytics space, I would like to highlight Dremio for data location abstraction, but also security. Databricks for its analytics capabilities, and Cirrata on its strength in migrating large data workloads while they are live. Now, in every application world, we have modernized workloads, but you always discover something that could not yet get migrated. It's just pointless to migrate, but it still needs to have access. For these cases, you can use the Blob and ADLS API to write your own abstraction layer, but also use protocols such as NFS or SFTP. They all share the same storage layer and security mechanisms, so there is a homogeneous setup possible, including HA and DR. Dremio helps with the data and security abstraction and makes data better usable even while it transitions to the cloud. Later on, through the abstraction of Dremio, it can be analyzed well with tools such as Power BI wherever the data is. With this, I would like to hand over to Johnny to introduce you to Dremio Cloud for Azure.
Now, before we get to Dremio Cloud and building out our lakehouse within Azure, let's take a look at really where we came from and why we are at where we are today. So if we take a step back in history, all the way to the 80s, how did people fulfill use cases that they had around the analytical space alongside day-to-day things that they really needed to do? They were able to do this using enterprise data warehouses. These typically sat on-prem. Actually, they almost entirely sat on premises. And they had fixed compute and storage capacities, meaning that as the number of use cases increased, well, we had to alter the infrastructure that we were using there. These became quite hard to manage because, as you can imagine, as we're looking to expand those use cases, it then makes it somewhat challenging to expand the compute, the storage, etc. Step forward into the early 2010s, and this is when Hadoop and the open source really started to explode. We saw a number of good common projects that were started, the likes of Spark, Parquet, Hadoop, generally, etc., etc. But one of the real challenges we started to see here was that there were so many different components. People were unsure of which components were going to be productive for them. Some of the advantages that we got from this ecosystem was, though, that we could add commodity hardware into our cluster whenever we needed to. So as the number of use cases expanded, well, we could quite easily expand and bring on more infrastructure in order to facilitate that. Then after this time, we saw that this was somewhat of a challenge to people, for people to get their hands on, for people to get familiar with, for people to get productive with. Because this was quite a technical ecosystem, it meant that the business value couldn't really be fully achieved within this ecosystem. Alongside that, performance was a major issue that people were experiencing. So there started to be a transition up to the cloud, taking things away from the on-premises ecosystem up to the cloud. Now, one of the things that the cloud was able to really achieve was that ability to burst scale. So within data warehouses, where we had those issues about not being able to scale, now we were able to scale. And we would be able to do that on a whim. If we had new use cases, we could instantly scale up. We also had taking place some of the major advantages that came from data lakes, the separation of storage and compute. So I mentioned about being able to increase that capacity. That could be either in terms of the amount of data that we were looking to bring into our analytics, or it could be in the amount of compute that we needed in order to fulfill the different use cases. One of the disadvantages here, though, was still seen from the data warehouse world, which is we had to load data into a proprietary format. So all of those good things around the open source ecosystem, such as Parquet, ORC, etc., those were not usable within cloud data warehouses. It gave people a bit of a lock-in environment, which meant that it was challenging to start to facilitate a number of these different use cases that had different shapes and sizes to them, because data warehouses are really constructed for classic data warehouse workloads. Alongside that, costs tended to escalate. They tended to spiral as we really needed to burst on that capacity. Along came the data lakehouse, and this was able to leverage some of the great things that we had about both cloud data warehouses as well as data lakes. And we could still leverage some of those open source technologies, and actually these have been taken further. These have been taken further, introducing core concepts such as tables into a data lake. It also meant that we didn't have to copy and move data into these proprietary formats. We could actually leave data where it landed. It also meant that we could, within that separation of storage and compute and also data, that actually multiple systems could understand what the data format was, meaning that if I'm looking to facilitate a number of these different use cases with their different shapes and sizes, I can find the best compute engine for my use case. Alongside that, I can leverage the best table format. Now, we've tended to see that a number of people are gravitating towards Iceberg as their table format of choice, so that they can actually leverage a number of the key functionality differentiators, making performance improvements and data more accessible to the masses. Now, what we really now need, and we've seen this come within the last year, is our data lakehouse 2.0. Now that we've got all of these great data table formats, what we need to do is organize them. And so people need the likes of a semantic layer to really have this orchestrated successfully, to be able to manage everything together. We've also seen needs for things like multi-table transactions to ensure that data is consistent. Within this ecosystem, this is where we see products such as Dremio thrive. We've worked in the open source heavily over the last number of years, refining a number of these projects, adding functionality. But what we're now doing is adding on things like an autonomous semantic layer so that people can start to add business value on top of their perhaps more technical data. And they're being able to add things like data as code as well. Data as code is incredibly powerful because it allows people to sample with data, but also develop on data, transitioning that data as a first-class citizen up the various layers through development, UAT, production, ensuring that at each stop along the way, we have that consistent structure, but we also have consistent data. We're no longer separating out, this sample data that we're working on within a dev environment with no idea whether or not something's going to work in production. Now that we've covered some of the history of how things have transitioned over the past number of years, let's take a look at how people who perhaps are a couple of iterations behind go and get the value out of these new technologies that are appearing. And so we'll do so by looking at first where people are coming from today. The challenges that people face is they are typically landing data in data lake storage, which is great. These are coming in open formats such as Parquet, JSON, CSV, etc. In the majority, some workloads are still landed within databases, whether or not those be relational or NoSQL. Again, it's going to depend upon different use cases that people have. And we now want to add business value to that data. Because we're bringing in these several different formats, it's going to be hard to bring all of those together. So the typical way in which people have achieved this over the last number of years is to really ingest that data into a data warehouse. This could either be a cloud data warehouse or still a typical on-premises data warehouse. Then what we're really doing is taking all of that great stuff that we've landed within the data lake and we're adding on that proprietary storage, meaning that we're no longer able to get value out of it by multiple compute engines. In order to transition that through its various phases. I will look to persist data in multiple ways, shapes, and forms as I transition things, as I perform my long haul ETL, as one might say. Now, on top of that, I'm going to have different data science reports, dashboards, applications that all use this data. They're all going to be looking at this in a slightly different way, depending upon the use case at hand. The challenge here is then I start to have a semantic layer that has various cubes, extracts, and aggregation tables that have been added. These are incredibly hard to manage and maintain because these need to be updated daily, sometimes hourly. That means that someone has to manage that pipeline. Someone has to manage to ensure that the data is up to date. That causes our expenses to rise quite significantly because, number one, I need technologies to manage this process, but also I need people to manage this process because we know the requirements are likely to change over time. Other issues that arise from this is my semantic layer has to be locked down quite heavily. We can't necessarily expose all of our data out for self-service. We need tight governance. So this tends to be controlled by a smaller number of people, meaning that those who are working with the data, transitioning it through the various layers, are not those who actually have the requirements and who know what needs to be achieved. Also, with a number of those copies, having those different security and governance rules applied then becomes, again, expensive because there are various copies of really what is the same data underneath the hood. Now, what we've seen people transition to is leveraging that lakehouse instead. Now, we'll see that we have still our multiple data sources where our data is landing. We're still going to be having our ETL pipelines that occur to really bring things within our lakehouse. This could be a number of our open source technologies. Within having that separation of storage and compute, as mentioned, we can leverage those different types of engines in order to really achieve that. And we can have those multiple systems address our downstream clients, whether or not those be across the data science world, or if they're in the more traditional BI applications. Within transitioning to a warehouse, what we're really looking to do is reduce complex transforms or transformations that occur within Java, Scala, Python, etc. Wanting to move them to be something that's simpler using SQL, as this tends to be the language that people within the warehouse world have really been familiar with. So it then requires us to not transition the way in which we perform our ETL. We're also looking to transform the full life cycle within the lake. So we want to keep things in that same ecosystem rather than leveraging several different storage technologies. A lakehouse will give us these advantages where we can keep all of that data living directly in our data lake. Alongside that, there are various advantages that people realize by moving to a lakehouse strategy. Because, as mentioned, we've got those open data and table formats, means that those multiple compute engines can read. We'll also have that compute and storage still separated with elastic engines that are around them. We'll have that no copy architecture, ensuring that as things transform throughout those various steps, that we are enriching that and not copying data in its base form to another place where it has the same base form, but just in a different format. We also will be able to support all of these ACID transactions. So I can do my create, read, update, delete on a row level, and I can ensure that I have that ACID consistency. Some of the advantages that we've also seen realized here is the ability to time travel. How did the data change from 1 month ago to today? I might want to take a step back in time and start to determine why I made some of the decisions that I made. That alongside the compelling economics of being able to scale as and when needed, but do so without needing to have huge amounts of cost associated to it. Now let's take a look at how Dremio is unifying this lakehouse platform within the Azure ecosystem. So what we'll see is that down in the bottom layer where we're landing all of our data, that's still going to be done in the exact same way as I just described. People are going to land within their Azure Storage. If they need to, they can even leverage data that comes from other cloud vendors as well to start to bring that into their Azure ecosystem. On top of that, we would be operating within Dremio, and we'll dig into those various boxes in the center in a second. And then downstream of that, we would be having people achieving their data science, dashboard, and application workloads, and they'd be doing so on a common semantic layer. So let's jump into the Dremio side. First of all, our entire data plane is going to be within the Azure ecosystem. So when Dremio is looking to start up various compute engines, it's going to do so on Azure virtual machine scale sets. Underneath the hood, what Dremio will have within it is unified analytics, a SQL query engine, and lakehouse management. Now, when we think of that unified analytics, what Dremio is going to provide is our self-service analytics. And it's going to be achieving this through the likes of our universal semantic layer. As mentioned, this will be accessible to each and every one of our applications downstream, and it provides security and governance on top of that, meaning that we can enrich our data, but also ensure that it is controlled as per the requirements of our enterprise. So that if we have rich role-based access controls, that we can achieve those. If we have data security requirements, use case requirements that are tuned very specifically to different dashboards, different BI, different data science workloads, these can all be achieved whilst also preserving that security. On the SQL query engine side of things, Dremio gives us that price performance that we need. It allows us to accelerate workloads without necessarily the need to scale up to large amounts of compute for high cardinality workloads, alongside being able to federate across existing relational sources that you might have within your wider analytics ecosystem. For lakehouse management, Dremio is going to keep everything that we've done managed. It's going to ensure that as I make changes, these are tracked. So I've got that Git for data. As I perform DML, as I create a new view, as I change that view, all of this is going to be tracked, and I'll be able to go back in time and make adjustments based upon the changing requirements that I may have within my organization. Dremio will also ensure that we don't get into that small file problem. It's going to perform data optimization, and it will also vacuum, providing for the types of housekeeping tasks that are required on top of data lake storage. Dremio Cloud is available in both a standard edition and an enterprise edition. The enterprise edition adds on that security functionality as well as enterprise support. But when we think across that unified analytics, SQL query engine, and lakehouse management, these are all also available within our standard edition. So people can get started for free today. Now, what does that achieve? That allows us to shift left in our mean time to insight, meaning that we no longer have to go through all of these complex requirements processes. We can also shorten our ETL pipelines because we're no longer copying that data. It means that we're operating in a single location. Dremio gives us the ability to get to production in a lot quicker time, whilst also removing a lot of the complexities that people have to deal with today. Meaning that I'm going from my data sources right the way through to my clients without any need to extract, aggregate, etc., and have people exposed to those aggregate tables or cubes. So within that shifting left, what we're really be able to achieve is that intuitive self-service experience, meaning that people can operate directly on top of the data and that they can get productive as soon as they're able to bring that data into the ecosystem, as soon as it lands. Within that intelligent query engine as well, Dremio can do the likes of ensuring that you're able to analyze data in the right type of way. By using text to SQL, as well as automated tagging, Dremio can start to provide that information that you need about your data. And with those next generation data ops capabilities, that allows us to be able to manage the data effectively so that I no longer require people to manage this. All of this is available within the Azure ecosystem. Now, what we're going to jump into is a little more about how I go about getting value downstream as well, how I'm going to use analytical tools such as Power BI to get some of that value as well, to start to analyze that data in real time. So I'm going to pass across to Hanno, who's going to walk us through the Power BI advantages.
Microsoft Power BI is a cloud-based business analytics service that helps to analyze and visualize your data to generate insights. Through Dremio, you're getting less dependent on where the data is stored, so you could consider Dremio the glue between your data and Power BI. Since it's web-based, you can use it on any device that has access. Its ease of use helps business users to analyze data also without being an IT professional, for instance, using natural language. Power BI comes with some key benefits, for instance, pre-built content packs like dashboards, real-time dashboards. You can use natural language to query your data. It integrates with familiar Microsoft products and enables single sign-on with Dremio Cloud. And through its nature as a cloud service, it's very fast to deploy.
So let's go through a quick demonstration of Dremio. First, to get started, if you don't already have a Dremio Cloud account, what you can do is just come to dremio.com/get started. Then over on the right-hand side, you can register to create your own free data lakehouse. Now you just enter in some details here, click the Dremio Cloud fully managed, and then at that point, you'll be ready to get started. Now, I've already got an organization and I've already got a project created inside of my Azure account. That's all linked up. Now, the first thing I'm going to do is I'm going to go and log in. And what you'll notice with Dremio Cloud is we have SSO throughout. So in logging in, you're going to be using single sign-on. By default, you will have options to use social login, but you can also log in with Azure Active Directory as well with our Enterprise Edition. Now I'm going to first log in and select my account, and I'll give you a quick tour around what you can expect from Dremio Cloud in Azure. So I've actually landed here inside of that Azure project that I already have started up. I've already created a number of sources, and a few of them are going to Azure Storage. One of them is going to also a Postgres database. And also I actually have something coming from a completely different environment as well. I've got this landing zone, which we'll go into in a few moments, but this is connecting across clouds to S3. What I'm going to want to do is build my lakehouse on Azure, but I can use other cloud sources in order to build that lakehouse. Down here, we have all of those sources where I'm connecting to those external locations. Those could be, as I mentioned, across object storage, as well as across relational sources as well. In order to add a source, we'll click on that Add Source button, and then we can see a number of options that we have here. They go across object storage, data warehouses, relational sources, etc. Above that, we have our semantic layer. And this is actually unique in that it's a catalog that's fully managed by Dremio as well. This catalog that's managed is versioned, and I'm currently looking at my main branch. We'll jump into some branches as we go along. We can see I've got my staging, business, application layers. As I progress things through my semantic layer, what I'm going to want to do is start to enrich that with some business information and then progress it downstream to actually how I'm going to look at this within Power BI. If I take a look inside my staging area, I'll see that there are some views that are already created. These are iceberg views. And if I jump into my ecom, which is actually where we're going to be looking at our use case today, I'll see a number of tables that have already been landed. Now, these tables themselves are stored in an iceberg format, managed by Dremio, and they all live within my Azure Storage, which is in my subscription. Alongside this, I can start to run queries. I can also examine previous jobs that have been run, look at the settings, and also run through some tutorials to get started. These are really helpful if you've not come across Dremio before and you're wanting to either learn SQL or you're wanting to learn how to work with your semantic layer. Now, as I mentioned, I'm going to want to start enriching some of this data. So I've already done so by taking some of my e-commerce data and actually started to add some views on top of that. I've also got this in an ecom folder, and here I can see I've added this into my customers, orders, and products. I've really just brought together through a number of joins these different data sets. Now let's take a look in at my customers first, and we'll see I've extracted out of a complex data type, the longitude and latitude. I've also added in a filter clause as well as joining the two tables, my customers and customer addresses. I've done the same with a number of the others when we are looking at my orders and my products. Now I'm going to want to start to model out my use case for analyzing this data. As much as it's great to have all of this data controlled, what I want to do is really start to analyze and understand how the orders and have been taking place over the last number of years. Now, what I'm going to first do is create my own branch in order to do that. I'm going to work through some development, and then I'm going to push that into my production. Now, what I'm going to do is first jump into my catalogs. So if I take a look at my catalogs, I'll see that I've got these two at my disposal. One that's by Dremio Prod East US, which is related to my Azure project, and the other which is related to another AWS project. Now, I'm currently looking at the main branch. It's the only branch that we have here. I first want to go and create a new branch. And I'm just going to call this JD test, just for us creating things here. And what we'll see is that now creates me an entire environment where I can start to sample with the data. I can start to build my own views, test them out, make sure that everything's good before I merge them back in. Alongside that, what we can also see is I can tag my data. I've added the tag of gold to my main branch. I can also see my historic commits that have been performed and who they've been committed by. I can also jump into the data itself and see what some of the definitions of those are. For example, I mentioned my e-commerce data, which lives in my Azure Storage. If I want to take a look at my customer address, I can actually go in and see some of the settings, as well as how often I want to optimize this. And when we're optimizing that, optimizing a table, what we're looking at doing is taking a larger number of files and compacting them down into a smaller number. That really makes for more efficient queries. Now that I've got my JD test, what I really want to do is jump back into my semantic layer. And here I'm going to jump into that JD test. We'll see if I go into my application. I've already got a reporting layer that's been created, but that's currently empty. Now I want to start writing some queries in order to start to get this out into Power BI. I don't want to bring in my semantic layer to Power BI because that's going to add complexity. And if I'm using multiple applications to analyze this, I'll only be able to do that in one place if I've got that in Power BI. Whereas if I do it within Dremio, build my semantic layer here, then what I'm able to do is have that shared across multiple products. So I'm going to first actually jump in and create some view. So I'm going to create that in my application layer, and I'm going to create that in my branch that I've just created, JD test. So if I run this, then what's going to happen is that's going to, behind the scenes, start to run some metadata retrieval, and that's going to create that successfully. If I were to now refresh this page, then what I would be able to see in my JD test is that I actually have a new view. And if I look at the history, what I'll be able to see is from my previous commits, there was a create view that took place 34 seconds ago. So that was me creating that view. I can actually now look to accelerate the performance of this using Dremio's technology called reflections. So I'm going to do that just via scripting. I can also do that via the UI. But first, now that I've created my view, I want to actually merge this into production. If I look in my production environment, what I'll notice is that in reporting, currently nothing exists. It does exist within my JD test branch. So I'm going to first merge that before adding on these different reflections to this report. So if I run through these now, then what I'll see is that I've merged and I've also started to add on these reflection definitions. It's important to note that I can also, if going back to my main branch, I can go into my application reporting layer and do these via the UI. If I go into my reflections here, I'll see a visualized representation of what I've just created. So here I've added various dimensions and measures to these aggregation reflections. These are going to accelerate my BI queries. And I've also partitioned and created some measures as well. Now that I've got my view created, what I want to do is start getting out and analyzing this data from my e-commerce organization. Really want to start jumping in to see, has there been a Christmas rush before or after Christmas on particular types of things that we sell? And we really want to jump down into the row level fidelity of this data set to see the individual orders that have been taking place. So I'm going to analyze this data with Power BI. And first thing I'm going to do when I get in here is I'm going to refresh the data, make sure that I'm dealing with that latest version of the ecom report that I've just created. We can see the popularity of certain product types going across different states. North Dakota, for example, is got books as highly purchased, whereas all of the others actually have baby products as things that are purchased very, very frequently. So what we're going to do is, let's say we look and see how our DVD sales have been over this last number of years. Let's first jump into just DVDs, and we can see that we've got somewhere in the region of about 25 million items purchased in 2022. We'll jump into that. And we're now getting down to the individual months. Let's look at December to see if there has been that growth over the Christmas period. And if I look across individual dates, I'll see there's not really been a huge amount of increase over those last few days. In actual fact, my orders after Christmas seem to be a little higher. Now, let's actually jump into the 26th. And we can then see how that's looked. Looking across all of my states, I can see, for example, that Arizona that's got quite a lot of items that have been purchased. Let's jump into, let's say, one in particular. Let's go into Michigan. And see how things have been split across the state. Now, I want to jump into, let's say we pick kind of a rural area. Let's see if I go to White Lake. Down the bottom, what I'll see is all of my postcodes that are associated to this, this region. So if I jump in here, I've actually only got the one. And then let's actually go and see all of the individual orders for that. I can, within a few seconds, get down from those multiple billions of records all the way to my individual orders that I have here. Dremio in the back end is running all of these queries live, and that's my orders. We can see that they've all gone to actually the same person, and these are the different products that have been purchased by that user. They've set various different order priorities, and yeah, we've been able to get down to that row level fidelity all the way from the billions of records that we started off with. It's important to note that actually this is running in a live query mode. It's running in with direct query. If I jump into my jobs, then what I'll be able to see is all of these queries have been running over the past number of minutes, where actually each of the clicks that I had ran a query, and those are running in just a couple of seconds. Now, that's great for today, but what happens when new data comes in tomorrow? So we'll jump into looking at that. Now, I touched upon branching previously. Let's also go into how that branching can be usable across loading in new data and making sure that things are ready for production as well. We may want a particular time of the day at which things really land. So let's run this within my run engine. And what I'm going to do is take some data which is landed in an S3 bucket. I showed that that Dremio S3 bucket at the start of this demonstration. It's in my staging layer. It's in my ecom line items that we're going to be wanting to add it, all of this stuff, and it's in my landing zone where all of this data is coming in. And it's coming in a JSON file format. So if I run this, then what's going to happen is first, my Dremio executors are going to access S3. They're going to read all of that data, and then they're going to push it into my Azure Storage, and they're going to push that in to that new branch. And we'll see that this takes a few seconds to read all of the JSON files that I have inside of this location, or in this case, just this one JSON file. And that's actually going to then insert my records in. Now, as that second query is running, let's take a look and see. I had about 500,000 new rows inserted for my line items, and I actually had double that for my orders. Now let's do a quick comparison to see things across the two branches that we have. So I've got that main branch and I've got that JD test. I added that data to my JD test branch. So let's finally run a query on top of these two branches to see what's the difference in terms of the row count. And what we can see here is in my main branch, which is coming here from branch main, we'll see this both for my line items and orders table, and comparing that across my JD test branch. These are my two row counts for each of the tables and the differences. And these directly map up to the amount of data that was loaded. So that's great. I can now actually go and merge this in, much like I did within my view, and I can put that into production. Before I finish, what I want to also just show is how Dremio Cloud integrates with all of the Microsoft stack. I mentioned here all of our compute has been running on Azure Virtual Machine scale sets, but what I also want to demonstrate is how I can take this report that I have. Let's say I take this back up to, I'll drill back up to the top. And let's get this ready for going into production. So I'm going to publish this. I'm just going to save my changes. And I'm going to just save this in my workspace in my Power BI service. Great, I already have something that I can replace this with. So I'm going to publish that out. That's now been successfully published. Great, I don't need Power BI desktop anymore. I can now jump into my Power BI service. I'm going to jump into this ecom report that I have just created, I've just uploaded, and we'll see that now I'm loading my report. And this has now got the data set that we just pushed into our production, both inside of our Dremio environment, but also inside of our Power BI environment as well.
Now let's recap on what we've walked through today. Today, what we've shown is bringing data into our data lake within Azure Storage. We've then been able to unify our data platform, utilizing our unified semantic layer. We showed that the power of reflections gives us the ability to have very quick responses when it comes to our mission critical BI workloads. And we were able to achieve that by the distributed execution engine that's happening within Dremio, utilizing virtual machine scale sets. Alongside that, we're able to achieve rich role-based access controls to provide us with data governance, meaning that our downstream platform, and today that we were looking at Power BI, this could also be a Python notebook, someone running SQL on a SQL IDE, as well as a custom application that we may have built. We showed how this can be served up to those end client tools and that we can achieve the types of outputs that we need. Now, the benefits that we've been able to see off that is we didn't need to copy data. We were able to operate directly on top of that data, which sat within the lake. We didn't have complex ETL pipelines. Within our copy into, we were able to execute that within a single command, and we were able to perform a multi-table transaction. Because we were leveraging on-the-fly compute, we then didn't require 24/7 compute to achieve what we did. This means that we can overall lower our costs. Within that unified semantic layer that we saw, we're then able to provide self-service analytics, as well as we were looking to improve data engineering productivity by simplifying things, leveraging SQL, which our data engineers are highly proficient in. We saw that security side of things, ensuring that operating directly on top of the lake did not compromise on any of the data security that we had within those existing files that we saw that we didn't have to compromise on our data security in operating directly on top of the data lake. We within Dremio were able to add on those role-based access controls and start to ensure that the right people had access to that data. And we were able to give consistent data at the end of the day. We were able to ensure with that multi-table transaction that we performed that we didn't have tables that were updated at different times. Now, I just want to finish by saying thank you to everyone who's been a participant here today. Thank you, Hanno, for walking us through the Azure side of things. Thank you, Alex, for your introduction at the beginning. I'll now open the floor to questions.
So I think what we're going to do now is we're going to kind of skip on to the Q&A section. And it's been good to see that there have been a couple of questions there have been a few questions that have come through as we've been rolling through. So what I'll do is I'll pick up some of these now, and then we can hopefully look to tick them off. And hopefully this will be beneficial as well for those who've been adding questions as we go along. So I think there were two distinct questions which both touched upon the same topic, which was in essence, Dremio Cloud support of Delta Lake. We walked through in the demonstration and touched upon how one can create tables using Iceberg, but there was like some questions that were, one was to do with is Microsoft or Azure perhaps more slanted towards Delta as opposed to Iceberg? You know, where does Dremio sit in terms of that overall support for the two of these? Now, I'll pick that topic up directly. Dremio Cloud supports both Delta and also Iceberg. Now, on the read path, Dremio can read both. On the write path, Dremio writes into Iceberg. It can also write into Parquet as well. We actually can't write into Delta, and that's primarily due to the read and the write paths being accessible in and out of the of Spark Compute. And Dremio doesn't run on Spark Compute. It runs in its own separate engine, which in essence means that for the write path, that's closed off. Now, we've tended to find more generally that across different table formats, with Delta and Iceberg being the most popular two, that different table formats are going to fulfill different use cases. So within that ecosystem, we don't want to block off either of those, meaning that because of that fact, we can actually look to read on both of the sides as well. And as both compute engines as well, both Spark and also Dremio can both read and write, they can both read Iceberg, then that should mean that actually if one is picking Iceberg, or if one is picking Delta, or if you're actually picking, and this is something that we've seen come up quite frequently. A combination of the two, that then you will not be closed off to using either of the computer engines there. So that gives you the ultimate freedom to dictate, do I want my pipelines to be fully run within the Spark ecosystem? Do I want them to run in a combination of Dremio and Spark? Do I want them to fully run within Dremio? None of those are actually going to be closed off to you. So I'll restate it again. Dremio Cloud supports Iceberg as well as Delta Lake. That's kind of on one of the topics. Another question that came through was related to, I'll call it data locality. Let's say I'm running Dremio, as I was in this case, in US East or East US, and I may have files which are not in East US. I may have some on the East, I may have some in the West, I may have some in Europe. Now, with the way in which Azure Storage works, ultimately there is no locale that's associated to that storage account name, which is great because we can ultimately access that from anywhere. Now, the question then led on to, where does that compute ultimately happen? Is Dremio able to push down? Is there basically copying of data, that type of thing? So when it comes to Dremio running that compute, what we don't do is we don't store any data on the side of Dremio. That will still fully exist within your Azure account. We are still able to push down so that if people do have, let's say, partitions that are on tables and they want to filter that down to, let's say, a particular date. Date's very frequently used for partitioning tables. So if we run a query that only is only filtering to a specific date, then yes, that filter will be pushed down so that only the appropriate data is read. Now, that does mean that where that data is being read from is from a more distant location. And that's why Dremio looks to bring in a number of clever caching technologies that is performed on the executors themselves in order to ensure that, we may see that there is a slower response time the first time we run that query, but as Dremio starts to build up that cache, as the data is read more frequently, that will start to, in many places, kind of bring that data a little bit more local to the Dremio execution. So that should mitigate any issues that one ultimately sees from accessing really remote data, particularly with data lakes. So that hopefully covers that. And we also had then the question leading on to, okay, can I also, if I've got these multiple regions and I've got these multiple file types, can I federate across the two or across the different dimensions? And once again, the answer is yes. Within Dremio, you can federate across multiple sources. You can still build that federation either into your semantic layer or within a specific query itself. So there's not going to be anything that closes you off to say specific regions or specific file types or even source types within a single query. So I think that's the questions that I have down here at the moment. I'm not sure if there are any other questions that we have coming through on the chat either. Cool. I think that's it for us. Well, I would like to thank everyone for taking the time to attend today. I know for some it's growing later in the day, so thank you very much for your attendance. We're really excited to get going with Dremio Cloud inside and being able to deploy executors within Azure. So once again, thank you very much to everyone, and really hope to see you guys soon, hopefully on the other side of the screen, where we're kind of continuing to talk Dremio and continuing to talk Azure. Have a great day, everyone. Thank you very much.